Everyone, here's a video on chapter 7-4. This is about properties of logarithms. Alright, so before we start talking about some properties of logarithms, remember that logarithms and exponential expressions are inverses of each other. So we can use properties from exponents in a certain way whenever we are looking at logarithms. So up at the top here I say, remember that to multiply powers with the same base you add exponents, so multiply and add go together. So looking at this chart here, it turns out that the logarithm of a product is equal to the sum of the logarithms of its factors. So if we have log base 3 of 10 times 100, I can split that. Remember, multiplication and addition go together when it comes to exponents, into log base 3 of 10 plus log base 3 of 100. So if it's multiplication, I can split it into separate logs with addition. I can also go in reverse from that if I've got two logs being added together of the same base. In this example, you see there's a base of 3 on both of these, so then I could go backwards with it as well and multiply them back together and get log base 3 of 1,000. So looking at example 1 here, express as a single logarithm, simplify if possible. So I've got log base 4 of 2 plus log base 4 of 32. I'm going to combine this into a single expression. Log base 4 of, because I have addition here, I can multiply these two things together. 2 times 32, well, it turns out that is equal to log base 4 of 64. And if I think, okay, 4 to what power gives me 64? Well, 4 to the third power is equal to 64. So log base 4 of 64 equals 3. And that would be the simplified expression. Similarly, I have subtraction. So if multiplication and addition go together, then division and subtraction go together. So if I have log base 5 of 16 over 2, I could split that into log base 5 of 16 minus log base 5 of 2. And you can go either direction with that. You can combine them back together as division as well. So if we have express log base 2 of 32 minus log base 2 of 4 as a single logarithm and simplify if possible, because of that subtraction sign, I can make this into a single logarithmic expression of log base 2 of, take the first one divided by the second one, so 32 divided by 4. Well, 32 divided by 4 is 8. And 2 to what power will give me 8? Well, 2 cubed, or to the third power, gives me 8. So my answer is 3. Okay, here's a neat property about logarithms that it can be very helpful. So say you have something like log of 10 to the third power. Remember, if the base is not written there, it's the common logarithm, and your base is 10. So what I have here is log base 10 of 10 cubed. Well, 10 cubed is the same thing as 10 times 10 times 10. And using the property that we just learned, if I've got multiplication, I can split that into 3 separate logs. So I'd have log base 10 of 10 plus log base 10 of 10 plus log base 10 of 10. In other words, I have 3 times log base 10 of 10. Easy way to think about it is to take that exponent, and this only works if you have a log here, and move it to the front. So that would be 3 times log of 10. So using this awesome property we just learned, let's look at these couple of examples. I've got log base 3 of 81 squared. So I'm going to take that 2 and move it to the front. So I'll have 2 times log base 3 of 81. 3 to what power gives me 81? Well, 3 to the fourth power equals 81, but don't forget about that 2 that was in the front, and so we'll multiply this now. So we have 2 times 4 is 8. Let's look at example B. Log base 5 of 1/5 to the third. Again, take that exponent, just go ahead and move it to the front, so we'll have 3 times log base 5 of 1/5. Okay, so that 3 will stay there in the front, but 5 to what power gets me to 1 over 5? Well, that flips, so that means that is a negative 1. So 3 times negative 1 is negative 3, and that is our simplified expression. All right, moving on. We have inverse properties of logarithms and exponents. I can't tell you how many times I have said, either in videos or in person, that logarithms and exponents are inverses of each other, therefore they would cancel each other out. Well, that's a good thing whenever we have problems like these three. So I'm going to show you why it is that I'm about to do something, why things cancel out, and you'll be left with an easy little answer whenever you see something like this. I'm going to show you the long way and then basically, in summarization, the shortcut. So, on this first one, I have log base 8 of 8 to the 3x plus 1. So if I'm looking at log base 8 of 8 to the power of 3x plus 1, I'm trying to think, what is that equal to? Well, if I rewrite this as an exponential expression, so I'll have this base of 8. What it's equal to will be my exponent, so 8 to what power? Question mark. 8 to the question mark equals the 8 to the power of 3x plus 1. Okay, well if I've got 8 to the something equals 8 to the 3x plus 1, that something must be 3x plus 1. So that would be our final answer right there, that log base 8 of 8 to the 3x plus 1 is 3x plus 1. So that's the long way of figuring it out. Or you can see, if I have log base 8 of 8, well that's just equal to 1. And remember, a log is equal to an exponent, and if I move this 3x plus 1 to the front, I would have 3x plus 1 times 1, or just 3x plus 1. Or you could just see that log base 8 of 8 cancels, and you're just left with that exponent. Let's look at another one. Okay, so I've got log base 5 of 125. This is really an example where you would just go straight into 5 to what power gives me 125, but just for the sake of using this awesome new property we've got here, I'm going to rewrite 125 as 5 to the third. Because now we know if we have log base 5 of 5, that would cancel, and we would just be left with the 3, and that would be our final answer. And similarly, instead of having log base 8 of 8, and I'm sorry, I've scribbled all over it so you can't even see what I'm pointing at anymore. We had log base 8 of 8, and we were just left with the exponent. Well, if I switch that around and I've got a base with an exponent of log base 2, those things would cancel as well, and you would just be left with the 27. One more thing to look at and then we'll be done, and this is the change of base formula. If we have log base b of x, we can split that into log base a of x divided by log base a of b. In other words, you take that of part, and that'll go on the top, and the base part will go on the bottom right here. And we can use this to change it into a different base. For example, if we had log base 4 of 8, and I wanted to change it to base 2, then I could take log base 2 of 8 and divide it by log base 2 of 4, and that would give me my answer. So let's look at log base 4 of 8. We have two different options here. So I can go straight into using that change of base formula. So I'd have log base 10, because remember, if it's not written, it's 10. So my method 1 is to change it to a base of 10. So I'd have log base 10 of 8 divided by log base 10 of 4. Well, 10 to something gives me 8, but I'm not really sure what that is. So you could take each of these things, plug it into the calculator, and you would get 1.5. Or if you don't have a handy calculator with you, we know that 8 and 4 are both powers of 2, so we could change it to base of 2 before we divide it. So if I want to change it to a base of 2, I'll still put the log of 8 on top, but this time my base is 2 instead of 10 like it was on method 1. So I have log base 2 of 8 divided by log base 2, again, of 4. Well, 2 to the third power gives me 8, so log base 2 of 8 equals 3. And log base 2 of 4 equals 2 because 2 squared is equal to 4. So log base 4 of 8 is equal to 1.5. And you could feel pretty awesome for figuring that out without a calculator. Okay, well, I'll see you in class, and I hope you're having a great day. Bye!